Hello everybody, this is the video 4. It's the one when we get Agentic AI on a Raspberry Pi working, and we can decide whether it's a worthwhile exercise or not. Well, it was. I learned a lot, and hopefully you've learned a fair amount as well. So this is how we started the day, with n8n on the wrong box. So we decided to get it correct. Yeah. So in Llama, we installed a few models. Llama 2 or Llama 3, I think it was Llama 3 I used to do the chat in the chatbot. And that MXBAI is an embedding model. We actually used a nomadic embedded engine at the end, model, sorry. But yeah, so that just shows you that a Llama has got 6 models. We had a 7th, and DeepSeek's busy running just now. Okay, so I've taken this from my database video. So we've got vector databases, and I thought I'd better summarise what a vector database is for this to make sense. So there's 3 common ones, which is Pinecone, Quadrant, and Weaviate, and they are all vector databases which are designed for storing vectors. If you can remember maths from when you were at school, what a vector is. So I've just done a mock-up of a 2D graph, vector graph, and unstructured nomic and the MPX are embedded models, so they do the algorithms for putting the stuff in. So if you can imagine, LLMs are stupid to some degree. So what they do is they rely on the vector database and the embedding model to describe what words are similar. So maybe on the right hand top right, we've got animals. We'd all go cat, dog. They're near each other. They're pretty similar. Fish is a bit different. Cattle's a bit different. It's a bit bigger. So it's all about word association, so that if it gets the word cat, kitten, it knows it's the same word, whereas maybe dog could be dog, spaniel, Labrador, and they'll all end up pretty close together on a vector. But in practice, it's made of hundreds of vectors. It's not just 2D vectors. Soup, it's a word on its own out here. And then down the bottom left, you get 3 fruits that are very similar: orange, tangerine, clementine. You know, they're all pretty similar. So that's how a vector database works. It's just so you get in your head why we're using the vector database and embedding models. So finally, this is the configuration we went. So on the right hand side, we've installed Quadrant, which again is just the vector database. We set up the port it's running on, and gave it some disk space. And n8n is working on the correct box now as well. We don't have traffic in front load balancing anymore. It's straight into n8n. I watched a few YouTube videos and they call it Nathan, which sort of mess with my mind, but being Scottish I get most words wrong, so I'm going to stick to n8n. On the left hand side, we got the nomic embed and text model, as well as the MXBAI model. We use the nomic text model. So they're used for embedding, and DeepSeek, Gemma, and Llama are used as LLMs. Okay, so that's the final configuration with everything working. Now this is n8n. This is the workflow we did. It's a traditional RAG model for a chatbot. There's no rocket science here, and you don't have to invest too much time learning it, because believe it or not, the AIs are now getting really good at coming up with n8n workflows. They can read, there's a repo somewhere of 3,000 good designs. They read it, learn it, and then they use it. So they're very good at doing the actual chat flow, the workflow, and for you it's more about what you connect where. So if we look at the workflow at the top, we click execute, and that reads and writes files from a disk. So this is to populate the memory store, so the chatbot's going to know what to talk about. So I downloaded 5 Ford manuals when we get to it. So it read the files from the disk. The embedding model did its algorithm on it and put it in the quadrant vector store. So we decided to use quadrant, and we use the nomic embedding algorithm. So that chunks. So basically, it puts them into small sentences so the computer can understand. So we've got 5 manuals chopped up into that in that vector store, and that's what the top workflow is. The bottom workflow is when you get a chat message, but equally, you could have it as a text message or a Telegram message or a Slack message. There's so much flexibility in n8n, it's brilliant. So we go to that. We've got an AI agent now, and the AI agent is, I think it's Llama 3 I used. It was either Llama 3 or Llama 2, but I'm pretty sure it was Llama 3 I used. So it's got an LLM to understand the question. It's got simple memory just to store about 10 conversations worth and stuff like that. And it goes and accesses the same quadrant vector store. In that, so we set a list of where the car manuals are, and then we use the exact same embeddings model to get the stuff back out. So basically, we've got an agent, and all it knows about is these 5 Ford manuals, and it listens to chat and answers. So this is how I copied the manuals. Came off the internet. I downloaded them on my Mac and then just used SCP, which is secure copy. It's just how I got them onto the Raspberry Pi, and we put them into the n8n file /Ford. Because n8n reads files from within the container in this configuration, I just put them into a location that the container can already see. You can see I use dark mode. That's why I use my son's Mac to get a screenshot of the last one in the white mode. But you can see it's working, and it's loaded. It's processed 5 items. It loaded 6. Just something that went wrong, but it's all good. Now I'll be admissed to say, I used nomic embedding. I used to work for Unstructured. Unstructured are the best by a country mile at doing the embedding stuff. They specialise in preloading and chunking up not just PDFs but all corporate data. They're really, really good. They are the best. I'm on a Raspberry Pi, so in the real world, I would probably do a call to their cloud to get the higher quality processing. One of the questions is about a fuse. The fuse is in a table, so it didn't read it. So ways to get the quality up is I would use Unstructured, and I would use ChatGPT or an external model to get the quality up. But for a Raspberry Pi, it's about learning. So we're using a normal embedding model, vector store, and an LM, and that's the fun about it. But you can understand you can get the quality of the questions better by using better tools. Unstructured do have an open source container, but it's compiled for x86 chipset, not ARM, so it wouldn't run. Or the last time I looked a few months ago, it didn't run on a Raspberry Pi, so that's why I've not used that. I've just used an off-the-shelf easy one, but the boys will give me stick. More of the chatbot we've done. It's going very slow. It took 19 minutes to ingest 5 Ford manuals, and then we used the embedding engine and put it in a quadrant vector store. Now I've asked the question, how often does my Capri need service? So one of the documents it's in is the Capri owner's manual. I'm not going to expect a Raspberry Pi to manage to do this quickly, but you can see the chat message has been received. How often does my Capri need service? The AI agent is busy reading everything. You can see the steps it's taken so far. So it's gone to the AI agent. It's gone to the AI agent. Connected trigger mode. And the step it's on just now, as you can see, is busy. It's busy reading the documents to come back with a proper answer. So I'll give you a screenshot once that comes back. Okay, so I think doing this project on the Raspberry Pi has been fantastic. It's learned a lot. It's been good fun. The quality of the questions probably benefits from bigger agents. So a bigger chat model, like using a 70 billion, it knows a lot more information than the 1.5 billion. So a lot of words have been truncated out, and I would use unstructured or a different embedded tool than the default one. But how often does my Capri need serviced? It didn't find that in the manual. It depended on the age and stuff like that, which is a valid question. What tyre pressure do I set for my Puma? It came back and it told us that the tyre labels on the pillar beside the door, which is a valid answer. And if you're wanting to look at your tyre, to prompt up your tyre, you could just open the door and see what it says on the plate. So that's good. USB port, I couldn't find, and I actually looked at the manual, and the fuse for the USB is in a table. And that unstructured, I've been in meetings where the data scientists and AI engineers talk about doing OCR and an image and a table and a PDF. So it's quite hard and it's complex. So the fact the base model didn't manage to read the fuse, I'm not too upset about. I was chuffed with what we could do in a weekend. It was a day and a half, and then obviously half a day of recording the YouTube videos. But it all seemed quite good. And then putting it all together, what we've achieved. So on the Raspberry Pi, we put on Ubuntu, we put on Podman, and we put n8n. So that's the technical stack of the workflow that we're looking at. So the workflow itself, for the top one, when clicking execute workflow, read write files from disk. So in the n8n container, we went to /home/Allen/n8n files, and then I made a folder called /forward. In this file forward, we put 5 PDFs. Then we went to the Quadrant Vector Store, which was on the Pod Raspberry Pi. So it was a Raspberry Pi, Ubuntu Podman. We used Quadrant, and the chunked up PDFs go in there. And the embeddings, they were done on the LLM Raspberry Pi. So it was Raspberry Pi, Ubuntu, Llama, using the Nomic embeddings model. So although the AI, if you go and get the AI to generate the workflow for you, you've still got to work out how to connect it and what components to build, which we've done quite successfully. And then the main chat message, we got the chat message. It was part of the n8n system. It was the default one, but we could have connected it to a different connector for text messages or signal messages. They're all there. So it's just a plug and place. So the AI agent, the LLM did the chatting. So that was a Raspberry Pi with a Ubuntu and a Llama, and it was a Llama 3 model from Meta that we used. We used a simple memory to keep track of conversations, and then it was the same vector store which was on the LLM Pod Raspberry Pi. Used Quadrant, the same Quadrant. It was actually the same equivalent to table. They called it a list, which we call car manuals, and then it called the same embeddings model. So all in all, I had a good fun weekend. I hope you learned a lot. I would, for production, I would use bigger LLMs or maybe use more horsepower than a Raspberry Pi. You'll get more so maybe a PC. You'll get much more accuracy with a bigger model and a better text embedding model. But everything works, and subsequent, I don't know how to present it in the video, but I'll show you tools like Google's AgentSpace, which is the equivalent to n8n. n8n give a cloud version rather than running a Raspberry Pi that's got more horsepower, but I found n8n itself quite usable on a Raspberry Pi. It was just the speed of the models, because some of them are designed for GPU. I've seen this week China's released some new models that look really efficient. So there's so much scope. The world's changing so much. It's learning, but hopefully you found the basics of this really good and you enjoyed it. And thanks for following me through this weekend.